like that. Now what I want to do is see if that works. Let's see. It does not work. Okay, and well, let me see here. Okay, so this syntax is incorrect. How am I supposed to do it? I am instead supposed to... Oh, well, let's see if this works. I don't think it will. Well, if I do it like this, this should work, I think. Math abs like that, and then this is also a function, math abs like that. Let's see if this works. I think it will. So let's try it out. Absolute negative 12 is 12. Okay, that seems to be working. And then now we do def pow is going to just be the same idea. CLJ hash math slash pow 1, 2, and then CLJS. Similarly, math slash pow 1, 2. Okay, so let's try that. Pow 3, 4. Okay. Is that pow can be implemented then as apply multiply to repeat n times the number you give it. So repeat 4, 3. So repeat 3, 4 times should be 81, right? Yeah. So you could, instead of doing this, you could actually implement pow that way. Instead of any reader conditionals. I don't know if that's smart or not. But anyway, I won't put that in there. Put a little note here. Move these to geom namespace. Get rid of those. Save that. This should work, no problem if I refresh it. Hey, that does change. Good. Awesome. So I'm not going to get into this Delani implementation on stream because I have to actually read through it more thoroughly. It might be good for me to make a blog post or something about it because that would help me learn it more thoroughly anyway. But that's for another day, I think. What I shall be doing in the meantime is I know what I want to do. Random with a seed, I wonder. Repeatable random. I wonder what this is. Ooh, a 2020 update. Okay. Oh, this is not what I need. What I'm thinking through here is just, well, so what I'm going to do now, this point set I had generated from a random, I built a simple random generator sort of thing. So if I go here, let's just add in a little thing here, define rand point, taking no arguments. Actually, it should take, actually, 1 second, rand okay, so rand appears to pick a number, a float number between 0 and whatever you give it. Ugh. What have I done? There we go. So I could do this, I could do n, and what it just returns is rand int rand int n, rand int n. I think that will produce 2 different points, or 2 different numbers. This can be 100. Oh, rand point. Okay, so that does work. Obviously though, I should do it as something like this. It can take none. I should give the user a few sort of ways to call the function. There's the no arguments approach, in which case it just, can you call rand int without n? What's a good approach there? Right, I could just do this. Not ideal, but let's just start. We'll do it like that. We'll do n, right, which does rand int n, rand int n. Again, well, let's do this. Rand int point. So we leave it like that. So it needs, there we go. So guaranteed it's that sort of thing there. We could do and in x and in y independent, which will give a point rand int and x and rand int and y. There's that. Then there's we've got nx1 and x2 and y1 and y2. Is that gonna work? I don't know. Rand int, and does rand int do? Oh, you know what? Let's not do that. Let's not go crazy with that. We'll just leave it at these two because that looks like it could be good enough. Oh, and I did this wrong here. That's that. That should work. Okay, so if I call rand int 100, no, rand point is what I mean. Okay, that's good, and then I can do rand point, let's say 200, 100. I think that's good enough for now. It's not completely perfect, but it will be okay. So define random points, and we take endpoints in the range. Oh, maybe I don't need a function for this. I could do it's not iterate, is it? This is not gonna work, I don't think. Oops. I only meant take 4. Yeah. Take 3. Yeah, this is okay. It's obviously not the right function. So I can't do this. If I take 10, repeat rand int point, it takes it, but it, like, the repeat just runs the function once and repeats the returned value, so that won't work. There is a way to do this. I always forget it. It might be do repeat, or it might be this. I don't remember. Nope. That is clearly not it. Is it, let's see, do times 10. Let's try that. Rand int point 100. No. Okay, let's just do 4. Huh. Oh, this would have to be like this, right? Okay, that works. I don't know that that's what I want. let's see, Clojure, do times, or it might not be do times, it might be something else. It might just be do seek or do, and I'm just not thinking of the right approach. I don't remember. Okay, maybe it's a do seek. Well, there's probably Clojure create list of random numbers. Let's see here. There's probably a smart way that I'm just not realizing here. Repeatedly. That's repeatedly. Okay, so let's try this. Take 10 repeatedly, where you do rand int point 100. There we go. That's what I'm looking for. Okay, that should work. That's pretty much exactly what I need. So I could do this into vector, take 10 of that, makes it a map, or not a map, it makes it a vector instead of just a lazy sequence, which is good. Okay, so let me just put a little note to myself here. List of random points can be created. So we do comment, and here we do into vec. Well, why not make it a function? Random points. N points and range. Eesh, that's a little messy after all. Well, no, let's do this then. We just do this. Random points with n. First with n, and then we do nx and y, which is just going to be okay, it calls itself, and then it goes here, and x and y, and it does into vec. Oh no, let's not do that. We actually just do repeatedly rand int point and x and y. This, by the way, I can actually do the same way. Oh, that should end up being the same. Should still work. Right, so this random points thing, if I do take 10 random points 100, okay, perfect. And it's a different number every time. Yeah, or different sets of numbers every time. I like it. So now, given that random points function, what I should be able to do over here is actually, instead of defining point set here, I should be able to call that function. So let's try it. dt slash give me 1 second, I gotta check something. I'm hearing a noise. All right. Where was I? Oh yeah. So this, I'm gonna attempt to use this random points function here. I'm gonna take 50 from the list of let's not do it that way. Let's just do this. A list of random points in the range. I think the range can be what's the range here? 400, I think? Yeah. 400. Let's go like that. Take 50 of those. Gotta close that there. Alright, let's see. Let's see if it works. Okay. Gotta refresh that. Yeah, kinda. No. Okay, something's goofed here. If I do, oh here, this is why. The points list was, I drew it on separately from the same point set, so that's obviously not gonna be good. So I need to for try in that whole thing. Oh, here, I can fix it by doing this actually. I can do I can make a let here. Let points be the call to be this here. Actually, let me do this. Delane equals this. It doesn't equal this. It actually, so the structure that, so this library I found creates a structure for this that's just a map that has keys, edges, points, and triangles. So I can just make the map here for triangles. So I can do this for try in triangles of Delane, like this. And then, oh, I have to close the let. And then here, instead of point set, it's going to be points from Delane. I don't know how to pronounce that or spell it, so I always mess it up a little bit. And then the let has to be closed like this. Okay, that should now match the points and the triangles almost. Right, so what happened here? Triangles. Okay, well, let's try triangulate. Did I spell it correctly? Huh, I'm in the wrong namespace? What have I done? Let's try this. Triangulate. There we go. Okay, so take 50 of random points 100. Let's actually take 10. Right, so this is, it has edges, triangles, and points. For try in triangles, right? I'm not quite sure what I'm missing here, but I'm missing something. Right, so it's clearly the random points list is working. Okay. First of this. Right, and can I run Polygon on that? Oh right. Load source silo. No. Okay, so that does work. So what's going wrong here? Let's change this to mesh instead. How about that? Mesh. Triangles from mesh. SVG path polygon try. This should work too, right? Yeah. Okay. Triangulate, take 10 from random points, 100. Okay. Let's do keys of that. Points, triangles, edges. Okay. Am I spelling something wrong? Triangles. Points is points. I'm confused. Let's have a look here. Fill, stroke, none. Well, okay. Now let's inspect. Let's have a look here. All these circles exist. Yes, yes, yes. If I comment this out, does it work? Ah, okay, okay. So inside the let, it's only running one, of course. What's the right way to do that? Does it do? Let's find out. Okay, I messed this up. Okay, there we go. So we see the points, but not the triangle. I always forget like the concise way to do both of these. I mean, I could do concatenate these. Seems like a cheat a little bit. It should work though. Yes, it does. Okay, so that's good for now. Let's so it actually runs it twice for some reason. So it runs it on a compile, and then at the end of the compile it goes again. That's strange to me, but okay. It doesn't really matter, and it seems to be working reasonably consistently, which is good. So if I now do 200, yeah, it mushes that in there. If I do 200, 300, it should be spread out. Cool. Now, if I do what happens if I take a small number? Or what happens if I take a big number? It slows way down. Cool. That's fun. Let's cut that in half and double this. That looks fun. Okay, so see, what I actually don't know is if this is actually calculating like the most optimal meshing. One thing with meshing is you want as few, like you don't want long thin triangles like this. They have a really big aspect ratio. They're very slender, and there's quite a few of those, but it is to an extent unavoidable with random point distribution like this, so you know it is to be expected. But I am wondering if the implementation I found here from this person Tristan on GitHub here, if they, oh, by the way, I should give that a star. I'm not sure if it is, strictly speaking, the optimal implementation, but for right now it totally doesn't matter. I actually am wondering if I do grid points like this, if I do grid points, what's the what's the right thing here? X, Y. Well, let's see here. I don't need to, let's do X, Y, NX, NY for now. So what you do there is the XY is the spacing between grid points, and NX, NY is the total number. So what you're gonna do is for X's range NX, and for Y's range and Y. For those, you give back a point, which is X times X times XS. Yeah, I think that makes sense. Y times YS. And that's it. Does that make sense? Let's try here. Grid points is going to be, X and Y is going to be 5 and 5 for 10 and 10 total. So it looks correct-ish. So let's go with that. Gotta zoom this out, please. Let's refresh the page just for kicks. One thing that this random points thing doesn't let me do is save a configuration of random points that I happen to like. So like refreshing this page will result in a different set of random points, right? There's a lot of gap there this time. I have no way of saving it, at least not built in, right? Like I could manually go and take this SVG and get all of its points back out that way, but that's not optimal. So it would be really nice to build a function that takes random points and will use a seed value so that you could reproduce the output based on the seed, like in Minecraft worlds, you can save the generated thing by knowing the seed of the world, that kind of thing. But I don't know how to do that actually, so I'd have to learn it. Anyway, that doesn't matter for what I'm trying to do today. Anyway, it's not a big deal. I do wonder what happens if I do the grid points instead of this. If I do dt/grid points and I do, let's say 10, 10, 400, 400, what happens? Oh, I don't need to take from that, of course. I just need to do it directly. Well, something went wrong. What did I do? Grid points is undefined. Oh, did this not save to the... Ugh, sometimes it's just silly on my end where I didn't save it into the... Like, it basically it didn't compile the change. No? Okay, let's do this. Thought this would work. Okay, we've got, there we go. See. Kinda. Ah, I slowed it down. It should work, right? Let me do let me stop it for a minute. Okay, we're not bogging it down. I wonder if there's divide by 0 or there's problems with really small numbers. I don't know. Okay, what am I trying to do here? Grid points 10, 10, 100, 100. Right, so okay, so there is something wrong with that. Let me try one more thing here. If I do 10 point, if I perturb it a little bit, does that make a difference? Not really. Yeah, so this is probably related to the implementation of the Delaunay meshing, checking if points are inside circles, and if you have a perfect grid, the perfect triangulation has ambiguity, right? Because you could generate like, if it's a perfect grid, that means you have a perfect square. So drawing the diagonal in one square makes a perfectly valid Delaunay triangulation, but also doing it on the opposite diagonal is equally valid, so there's no way for it to decide necessarily. I guess that might be what's happening here, because there's not safety built into the implementation, which is okay. It does so it won't work the way I want it to. What if I do gridish points, and what I do is this, plus plus a random number. I wonder if this will do what I want it to. We'll find out. Okay, so gridish. Huh. Well, that might also be the other problem, is there's tons and tons of points already. Am I doing this correctly? Oh, I've flipped. Well, let me... Well, it might just be that. I've inverted, that I've swapped the, yeah, okay, we've got, okay, so it's working. Let's try this now. 400, 400, 10, 10 should be at least more computable. Actually, you know what, let me do 20, 20, save that. Let's see if it'll actually work this time. Okay, so we've got that's a strange looking, that's weird. Okay. Once again, the same problem persists. I didn't save it. Eesh. That's me being silly. Okay, let's try that. See what it looks like. Okay, same sort of thing. Now, okay, if I do grid points, oh, yeah, see, this is why, like, these, I always confuse myself with this. I do want 20, 20, right? And the N refers to, if the grid size is 20 pixels by 20 pixels, let's do 10 pixels by 10 pixels. It's gonna be 40 by 40. That should be a reasonably sized grid, right? It shouldn't take too long. Well, maybe I'm wrong about that. There we go. Okay, so that's manageable, and it looks cool actually. So it does make a grid. It does work. Cool. Wonder if, okay, so if I do 20, 20, 20, 20, that should make the same size but double, or the same total. Yeah, okay, that looks pretty neat. Right, so that's grid-ish points. What happens if I run grid points? Will it work at all? Oh, of course. Now, grid points. Let's get rid of this random addition here. save that. Refresh this. Need to go like this. Now what? There we go. Okay, so that's a proper grid now. And then grid-ish points has basically some random perturbation around the points. So you're gonna get these, the diagonals will be in different, since some of them will be shifted more or less so that they're not perfect squares, it actually will have sometimes the diagonal will be optimal this way, sometimes it'll be optimal that way. Okay, so that works. That's pretty cool. I should call it cell X, cell Y, N X cells, N Y cells. So that is theoretically clear. And then this is cell X, and this is cell Y. And then this will just be sure, that should work the same. And this grid-ish points thing, I don't think I want a function like that. That's a little strange. Yeah, okay. So that should work all right. Now let me just see for fun here. Yep, it does indeed work. Cool, cool. I'm happy with that. These should be rectangular then, right? Yep. Okay, this is pretty nice. Okay, let's do actually 40 by 40, 10, 10. There, simple enough. Okay, so now, what do I want to do now? Now that I have some usable functions for triangulating stuff, that's good. What I want to do, so the idea I have is, oh, I have to take a call. I'll be back. Okay, right. It was important that I take care of that, so that's just unfortunate timing, but hey, you know what? Some calls take priority. Right, so where was I? I was thinking about the next step here for this Delaunay triangulation stuff, which will be what? What's the next thing to do? Okay. I am currently dealing with, let's zip that away. Okay. Draw 3D transform. If I look at that, it is not the points test, but this right here. Okay, so drawing 2D is the container element there. SVG/color is what's producing this. If I turn this into pink, it should change the, yeah, okay. Blue. It's fine, not the most beautiful color, but it'll do for now. Right, so this here is some sort of kind of wondering how to do this in a way that is useful, right? See, I don't want to have to manually add Z value points there. So let's go drop Z, add Z points. If I have a point that's 2D and I conj 0 onto it, that's what I need. All I need to do here is map v conj points. And that should work. Oh, I'm in the wrong namespace. It's fine-ish. It's just not consistent. Okay. Add Z, right? Should work on. Oh, now, of course it won't work. I have to do load, save that, and then do here load file, source, stylo, draw. Okay. Add Z should then work on a list of points. Yeah, so it just adds it at the origin there, which is fine with me. So using that function, these should actually be further up here probably. If I do this, drop Z, add Z. There's probably like more mathematical names for it, like lift or something like that, or yeah, I don't know. There's probably a better name for that, but that is okay for the time being. Right, so this is a bad name, actually. This should not be axes ISO instead, because 3D, like the isometric angle that this is at is only one potential view of it. So to call these the 3D axes when they have hard-coded in there the isometric orientation is a misnomer for sure. So I have to go where did they go? Here. Save that. Save this. It's not gonna work. Gotta refresh this. There we go. Okay, that's just a rename thing. The thing I wanted to do, let's see if I can figure out, right, so what I want to do is make a parametric surface, so the cylinder surface, get the parametric representation of that, and then using the parameters, it'll have two parameters because it's a surface. You can have a curve be parameterized by one variable and surfaces by two. So what I want to do is use the grid and the Delaunay triangulation on a randomly selected set of parametric points in parameter space that map onto a cylinder surface and maybe get a cool looking 3D cylinder thing out of it. So let's try that. No, let's not do this. Let's go here, split. Oop. Yeah, so this is a proto as well. We're in the draw namespace, which is good. Let's see here if this makes sense. Whoops. This is more what I'm looking for. It's not in English, but surface diameter height is equal to pi diameter squared over 4 plus pi d height, and then the derivative of that, which I don't actually need, I don't think. Okay, so am I looking at the right thing here? Maybe not. I know this isn't that hard. I've even done it before, but I'm not in the mood to try and derive it myself, to be totally honest. But this here, parametric surface, generally speaking, is what I'm looking at, right? So x and z. So this, right, is parameterized with v and u, and then you get out, right, you get x, y, and z out. So if you give it's like you're almost reducing, never mind, it's useful because you can map a grid over a 3D surface and do approximations and whatnot. You can do all kinds of cool stuff with it. Like that. That looks really cool in my opinion. Okay. I actually wonder, parametric, I had a few things here. Parametric circle. I have this parametric sphere. It's actually, let's mess with that for a minute. Before I go into the cylinder, I actually want to see what I can do with just a sphere, because the sphere is a nice simple place to start. Oh, geez. Wrong button. There we go. Okay. Boundary rep sphere. This function takes a radius for, if I def a as brep sphere with a radius of 10, let's say that, right? Now I have a is a function, and if I take a, it has 2 arguments, and I know that because here this is what's being returned, a function of u and v, right? If I do 0.5 and 0.5, then it gives me a point in 3D space. So this here, right, the way I've set it up, they're mapped between 0 and 1, right? So if I map uv over 2 pi, I'm just basically, I'm making it so that if you give u a value of 1, then it returns then it runs as 2 pi. If I didn't do this, if I didn't remap u and v to the range of 2 pi, then u and v would be passed in as radians. Instead, I just pass them in as percentage, like from 0 to 1. It's basically equivalent. It's just easier for me to think of it this way. I don't know if it's better per se, but right. So using this brep sphere function, there's an error somewhere. Oh, that's right. Cylinder. Yeah. Yeah, okay. So So what I want to do is draw I want to get the sphere points represented on here. So what I'm going to do to get that is get rid of this, get rid of this. Okay, let's have a look here. Instead of hex points, it's going to be sphere points. And sphere points are going to be, A is going to be sphere A is going to be brep sphere with a radius of 20. Seems okay, I think. And then def sphere points is going to be, if I do, let me see here, grid points. Oop. Okay, if I do a cell size of 0.01, 0.01 for a total of 100 cells, right? And if I do a count on that, how many cells is that? 10,000. Okay, let's try that. That seems it seems like it could work. We'll try that. Right, so define the grid as grid points 0.02, 0.02. That's the cell size for 50 by 50. Okay. And so then sphere points is going to just be map sphere A over the grid. So that's the sphere points, and that should work for me. But instead of running a polygon over that, I actually just need to run, let's get rid of scale. I basically need this sort of thing. Which might be a good approach. Yeah, let's do it that way. No, let's see what, just for the sheer lunacy of it, let's see what this looks like. It's gonna look ridiculous, but it will be fun. Okay, so sphere points should be a bunch of points on a sphere surface, theoretically. Whoa, geez, not what I need. Okay, let's save that and see what happens. I don't think it's gonna work. brep sphere, let's refresh this first of all. Let me zip that away, and instead of brep sphere, we have to do draw slash brep sphere. Grid points is dt slash grid points, and that should be fine. Now we uncomment that and see what happens. Okay, so we've got a whole big thing of nothing. If I try to recreate this in my REPL here, let's do that. Let's define sphere A to be brep sphere with a radius of 20. Let's try that. Okay. Now let's def grid to be stylo.delane slash grid points 0.02, 0.02, 50, 50, 50, right? And then we do define sphere points to be map v sphere A over the grid. Okay, so there's something wrong here. Take one, or let's do first from grid looks like what? 2D point. Last of grid is 9898. It's fine for now in theory. Okay. Right, it has to be map v apply sphere A, right? No, it has to be like this. Yeah, like this. Apply sphere A to these arguments. First of sphere points is a 3D point, and then if you drop z, right, which is what happens here, then you can run it through a 2D thing. Okay, so sphere points is map v hash apply sphere A to that. Save that, and I should maybe, yeah, awesome. Okay, that's really cool because it actually works. So so obviously this looks a little weird because it's a polyline. Let me make a bigger sphere as well. Let's do 120. Is that too big? Sweet. Right, so what you see, these little zigzags here are the jog up. So it's a single polyline tracing a sphere like this. So if I get rid of, if I don't do polyline, if I were to instead do this thing here, this for loop, but I run the for loop not over mesh but over sphere points, should see a pretty even distribution of points over the sphere. It looks weird at this angle, but that, yeah, I get it. They are all correctly, no, that's not the case. Oh, this is actually incorrect because what I haven't done is this. Yeah, let's do this. D slash drop z d slash orient iso sphere points. Right, so then this here, I can just do transform sphere points. I think that's, yeah, and then this here, XF sphere points. If I didn't mess it up, there we go. Right, so that's cool. Now, if I right now what I have to do is, if I want to map triangles over all those grid points, right now I need to right, so there's the grid. Def dt grid will be dt slash triangulate the grid, and then sphere points would actually be, that doesn't change, but then the triangles would be the triangles of dt grid. And then to draw all of those, you do this sort of thing here for try and triangles of that, but I have to actually do the transform triangles first. It's going to be d slash drop z, d slash orient isometric, of like this. I think that makes sense. And that should give me a list of triangles. And then here I basically just do this business. Instead of, well, doesn't matter that much. Let's go like this. Let's get rid of this one. Right, for try in XF triangles. I don't know if I'm thinking about this right. We'll find out soon. You just draw the triangles and then the, let's see if that works. Okay, we've got something wrong here, which is fine. We can work with things that are wrong. Ah, yes. Here, too many arguments to def. Define X triangles as this business here. Map this function over the triangles. Try again. It would appear I may have frozen it, which is pretty fun. Yes. Stop it. How about that? Let me go 0.0404 with 25, 25. Let's go with a smaller number. Stop. Let's go get rid of that, bring that back in just for kicks. Are you getting to a point where it's gonna work? Still slow, and that is because of, wait, is it still slow or is it just not working anymore? Okay, we've got something kind of working there. Let's add this back in. Well, let's take this out, right? If we take that out, so it's definitely slow when I'm running triangulate here on this grid. I'm pretty sure that's what's one of the causes of this anyway, because it's still quite a few points here. Let's reduce that number even further, and let's undo this and see what it looks like. Let's see what happens. Okay, so we've got a set of points at least, but we do not have transform triangles working properly, and that would be because of something I don't know yet. Oop. But I actually do have to be right back. Gotta go to the washroom. Okay, back at it again. Right now I'm having a problem with the display of the transform triangles here. Hey Melissa, converting a 3D CAD into an isometric drawing. Well, kind of. I'm working on, in general, I've got a library that I'm working on here that helps me make CAD diagrams to be used inside sort of documentation. And what I'm doing is working on the interface that, I mean, at its most simple, if I have a point that is three-dimensional, so 1, 2, 3, or 4 in this case, I'm working on doing a rotation transform on a set of points, and then you drop Z, and then you have the 2D points that you can use SVG to draw and create an isometric view of this sort of thing. So I'm kind of messing around with, this is a sphere, contrary to what it actually looks like, because I'm using a low number of points to discretize it, but I don't know if I'm answering your question. I'm not working with models directly at this time. Trying to get your head around it as you're an engineer. Oh, nice. So the high level view of what I'm doing is, in general, I'm making a library that lets you programmatically define CAD models. So 2D drawings, extrusions, assemblies of parts, that sort of stuff, in such a way that you can create documentation that has the description and the visuals of the models right in it, lets you change some things around, and then get eventually like step files and stuff out of the document directly. Define a model via matrix, which can be imported as visual in the technical doc. Yeah, kind of. So I have, so this is, like, I'm self-taught, so there's a lot of stuff that I don't know on the programming side of everything. I'm pretty experienced with CAD in general, but here I have a kind of rough example or two to show the like high-level ideal goal. So this is an older post I wrote showcasing some old code. This is, I'm not using this anymore. This is Python here, and I'm using here at Clojure. But I tried out creating programmatic models and displaying them in 3D in the browser, like you see here. All right in with pros, explaining the design, right? Going down, 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 blah, 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 blah. And then you see all the parts, you see the code, and you see the assembly here. The idea being that if you write a program to define the design intent, then you can get sort of parametric assemblies out of the thing at the end. So this is an old example of a thing, just a little thing I built. Some of the limitations of this example here, this is not interactive code. There's no way on the page to say, well, okay, so I wanted, instead of this being 40 inches wide, I want it 50, right? So anyway, a lot of this is me relearning a lot of that kind of stuff and how to implement it and hopefully write it in a concise way with good code and all that kind of stuff. So I'm not perfect, and right now in particular you're seeing me just kind of mess around. I'm not working particularly hard today. but that's the idea, and it's kind of cool. This sphere that you see in particular here, oh, I went the wrong way with things, is a, this is a boundary representation. There we go. See, if you make the grid spacing smaller and smaller, you get it, you can see it more clearly. This is some of the more basic fundamentals of one way that you can describe CAD models, right? So I'm trying to build the lower level pieces and then define more complex shape functions over that, which you can then use to make more advanced models more quickly. So you said you're an engineer yourself. What kind of engineering? Just out of curiosity. I feel like I'm not explaining myself particularly well today. I apologize for that. I'm a little tired. It's not an excuse. It's just not my not the fastest in the brain today, if that makes sense. Okay, so let me Let's see here. Oh yeah. There. Okay. This grid has 400 points. That's good enough for that. So if I I'm just stepping through what I wrote here to see where I went wrong. What I want to see is the Delaunay triangulation of the surface of the sphere. And I thought I had that working, but it isn't yet. So that's what I'm in the middle of doing. So if I do this stylo.Delaunay, right, so I've got that. If I take triangles from that and count it, 722 triangles, that's fine. If I take first of triangles DT grid, right, we've got the 2D. Oh, I did something wrong here. So the triangles here are 2D. This doesn't make sense here. This doesn't, that's invalid. This sphere points thing is fine. I'm going to move it up here. Right, so here, right now, so if I take the triangles here, for each triangle I can draw that, I have to convert that into, let's see here. These are parameter space triangles. See this, I'm really messing around right now, and the names of these are not, it's not conducive to actually understanding what's happening. I just want to get to a visual of the triangles first. I hope that makes sense. I do find like a lot of geometry related stuff is really confusing to explain verbally, but becomes a little clearer when you can put a visual to it. Oh boy. Since I'm sidetracked for a moment, anyone who's watching now, by the way, feel free to ask questions, chat in the chat if you want to, about this, about projects you're working on, about anything in general. You go right ahead. That's totally fine by me. If you don't want to and you're just cool with just listening and watching, that's fine too. No problem at all. Okay, so parameter space triangles, Delaunay triangulation grid gives me the triangles there. And now, so each of those triangles has 3 2D points. What I want to do with each of those is produce, so def triangles, sphere triangles, right, is going to be map. You have to run could I do yeah, I could. Here's what I'm going to do. these here, I can do, if you concatenate a list of lists, 1, 1, 1, 2, 2, 2, 3, 3, 3, that's done nothing. If you apply concat to that, yeah, okay, so I can go here and just apply concatenate to the list of triangles. So now it's a flat list of points, which is perfect. So what I can do here to make the sphere triangles, I can just map sphere A, apply sphere A to those points one at a time, like this. And then I have to just partition it by 3 for the sphere triangles. Partition 3, that whole thing, to get it back into a set of triangle lists. Should work. Then, oh, wait a second. Do I want to do it that way? Actually, let's not partition it. Oops. Partition later, because what I still want to do with these points, these will now be 3D points, and what I need to do is actually def xf sphere triangles parameter space. These are not triangles, they're just going to be a list of points. Sphere points. Boy, the names don't make any sense, but I want to make sure I can get some visual anyway. PS try points, PS try points, like that. So then transform sphere try points is going to be d/drop z d/orient iso over sphere try points. Yeah, and then here, now finally, I think this makes sense. We'll find out. XF sphere XF triangles now is just going to be partition by 3 XF sphere try points. Okay. Moment of truth. Does this create triangles? Whew! It does indeed. Okay, that is hard to see, but looks really cool. So let me get rid of the blue there. Sweet. Let's also, just for simplicity there, get rid of the red points too. Okay, that is, so that is really cool. The reason it's going to be hard to see it, well, one, I can't, I haven't built, it doesn't rotate because it's a static image now, but it's also not, like you're still, you can see through all the triangles directly. So actually, if I do, this probably won't make it any clearer. It might, we'll see. Cool, sort of. So it does appear like I have a hole at the top of the sphere here. It looks like it's not a completely closed triangulation. And that almost certainly has to do with how I spaced the grid out. I probably didn't go directly to the edge of the parameter space, which means the zero, like the very top of the sphere, I probably didn't reach that with a 1 or a 0. It's probably 0.02 and 0.98, so that the tops get chopped like that, which is going to be okay for right now. One thing, if I inspect this element here and just delete it, it might also be related to the order of things being drawn not matching the 3D projection of it. Let's inspect that one and delete that as well. Oh, okay, so it turns out I don't know what I'm talking about. Let's go back to fill none here. Yeah, okay, so it is actually filling out the top and bottom, but it's a little weird looking. That's okay though. This is kind of the step in the right direction for the next thing I want to do. Let's make a new, let's do triangulate proto instead. So how do I want to do this? Let's define, no, it's not going to be triangulation, it's going to be there. Define sure. And it takes in a surface function and a grid of points. So using that, right, it will return what'll it return? I can have it return the set of points in 3D that make up the triangles. That's what I'll do. It'll be a list of triangles with 3D points. That makes sense. Because then I can build out the rest of the stuff on my own to project it back into 2D. So, okay, so we have, basically I have to pay attention to this right here. These sets of definitions I have to turn into a function that ends up returning the triangles. Basically I have to go at this point here. Does that make sense? I think it does. Yeah, so here we go. I wonder if I can do this with the thread first macro. Okay, so we start with the grid, we triangulate it, then the triangulated grid gets concatenated, then that set of points gets mapped through the sphere, and then that gets partitioned back into 3 for, yeah, so let's see if this will work. Start with grid, map it through, or transform it by way of silo.delane / triangulate the grid. That returns a map, which we only care about the triangles for anyway, so we can just apply concatenate. Wait, is that going to work? That's not, well, we could actually just do it this way. Triangles. Then that list, we apply concat on that list. I think that'll work. Then we have to map hash apply sphere, no, apply F over that list. That should work. Then we have to skip this because we're keeping it in the 3D realm, so we're not projecting it onto the 2D view. And then all we have to do here is partition by 3 that whole thing. So let's see if that works as a function. Let's find out. So sphere A, right, is, did I define it in this space? I thought I did. I did. Okay. Right, so let's triangulate surface of sphere A with the grid wrong number of arguments. Oh yes, of course. This is like that. Let's try that now. Lazy sequence cannot be cast to. Something is wrong. Well, let's do as grid as grid. Let's see if this cleans up a little bit. Silo, triangulate the grid. From grid, It's not, maybe that's a bad name, but we'll see what happens here. G, apply concat to G, map, apply F, blah, blah, blah to G, and then partition by 3, G. Does that work? Unable to resolve G. Grid, G. Yeah, it worked. Cool. So, let's actually take first from this. Should be a point, yeah, it should be a triangle basically. Okay. That's pretty neat. So that's triangulate surface prototype. Using that, I should be able to also make, let's render render triangulation is very specific, and it's going to be triangles, and it's going to be 3D points. So this is where I'm going to transform things. So what we do is as triangles as t, here we run that through apply concat again, and what that does is just takes all of the triangles and keeps them in order, but it makes them just single points so that we can map things over the whole list really easily. Because what we need to do is map orient isometric over that list of points, and then over that we drop z, and then that we repartition into sets of 3 again so that they end up as triangles again. So let's see here if we take first of render triangulation of triangulate surface of sphere A with grid. Okay. I almost got it right. There's just this here. Let's try it again. So what I expect to see is a set of 3 points that are 2-dimensional. So we've got x, y, x, y, x, y. Perfect. That's exactly what I need. So using those 2 functions, I should now be able to clean this up a little bit by doing, so if I keep sphere A in grid, I should now be able to create this render triangulation is probably the wrong name as well. Right, because it's not perfect as a name, because, well, here what I need to do is technically for this to be, well, you know what, we'll leave it for the time being and then put a note here saying no, we'll just leave it for now. It's a bad name. I don't want to. It might project triangulation, isometric projection triangulation. It's hard to name these things, but that's fine for right now. These are all prototype things anyway, so I can worry about that in a day or two. What I want to do now is rewrite some of these things. Let me clean this function up a little bit there. Okay. That should still be fine. Yeah. Okay, what I want to do is get all of this cleaned right up. I should be able to delete these. I should also be able to create this transform triangles just by calling render triangulation on triangulate surface sphere A grid. Okay, this should work. Oh yeah, when I use the right namespace, draw / render triangulation, draw / triangulate surface. Let's try it. Yes, okay. That's working, which is very exciting for me. Now, if I do def random grid as grid is dt / random points, where random points are silo dot random points. Let's go between 100, like that. Take 10 of those. Yeah, and then if I do if I apply concatenate to that and I do map, divide those by 100 over this, and then there I do, oh, I gotta divide it by float value. That's not, that's this here. There's that, and then just repartition it again. Oops. Partition by 2. Did something wrong there. Right, so this define random grid is going to be, I want to do thread first list of random points. Take 100 of those. There must be a different way to do this, but that's fine for right now. Random points. There's a smarter way to do this. Let me do this. I think this will work. If I don't need to use the grid function I had there. I can just do, if I do take some number of repeatedly random No. Maybe like this? Yeah. So that should get me random points between 0 and 1. And I only need, let's say, 100 of those, so let's call random grid repeatedly random. Take 100. Let's try that. Then with that, all I have to do is try to run this same function, but with random grid instead, to see maybe it makes a weird looking triangulation. Huh, okay. Or not. Wonder if I broke it. It looks like I did. Oh wait, I have to do this. dt/grid. No, that's not true. Huh, this should work, shouldn't it? I thought it would. Let's have a look here. What's going wrong? Check the console for the errors. Uncaught. Nth not supported on this type. Oh, of course, this is... I have to do something like this. Hash into vector. I have to do hash, wait. I think that'll work now. Let's find out. Let's define random grid here. Oops, I don't need to do it. Nope, come on. Okay, that looks right. Let's try that. Nope, save this. Save this one. That's what I meant. There we go, okay. Cool. Kinda. It looks ridiculous in the best way. Fill, slate gray. I like it. It is totally bonkers garbage. Actually, let's do opacity 0.5. That looks pretty neat, actually. I kind of like that. It's not perfect though, but it is. So I think the opacity doesn't help this at all. I think that actually is a valid surface. The reason it doesn't look like it is actually just because the the paint order of the triangles is not going to correlate with the proper 3D space of it. So by that I mean it might be the case that a triangle that is supposed to be in front is drawn behind, because this is not sorted by any camera Z order or anything like that. There's no culling. there's nothing intelligent about it. It's just literally drawing all the triangles in whatever order they happen to be in. So by that I mean, like, if I delete some triangles, there's triangles behind it, and it's hard to tell what's supposed to be in front. So it's not shaded, it's nothing, like, it's just too hard to know if this is going to be totally valid. But I think it technically should be, because it's a valid Delaunay triangulation in the parameter space, which should map onto a valid triangulated surface in 3D space. Actually, I don't know that. Maybe it does, maybe it doesn't. It looks neat though. Let's take 200 of these. Let's take 500. Yeah, see, the higher the number becomes, the more spherical it looks. It's pretty cool. Pretty good. Ooh, I could also do random color here. That might be fun. Let me see what I can do here. Hue 245, saturation 50, 60, lightness 60. I think that's a valid color, is it? No, evidently not. Let me see. Let's go here. Let's do SVG random color. See if there's like a built-in. I don't know. Not quite what I need, but that's okay. It's not built in anyway. Can you do RGB? Oops. Would appear no, unless I just have the wrong. Let's go fill. I thought this would work then. Oh no, that's because this would have to be right. It's a style fill. The fill here. Shoot. Well, let's go like this. Let's mess with this a little bit. Fill. Yeah. This should work now, right? I think. No, I totally messed it up. Huh. Really? Well, okay. Gotta go for a minute. But before then, let me just do this. Fill none. Should get, yeah. Okay, I think I'm gonna work on this for about 30 minutes yet. I have basically the idea I wanted more or less working. It doesn't look like it, but the reason or the thing I had in mind was to actually do random Delaunay triangulation on a cylinder surface. Because the idea I have is to make like semi-random triangulated structures that I can bend out of rod and make like actual shapes and weld them together. So then you have this like cool sort of triangulated statue type thing. And I wanted to see if I could make like a table with where the legs are sort of smooth surfaces triangulated roughly. So then I have so I can make it out of rod pieces. And then what I would do, right, is I would go until I'd generate a bunch of different random ones, get the triangulation list out of that, save it, so then it stops generating new random ones. And then for each triangle, produce a little drawing that I can use as templates to bend all these triangles and just build out this big old thing. It seems cool to... Excuse me. Seems like it'd be cool to me. So in order to do that, let me see if I can now find a find a way to represent cylinders. Let's do that next. Cylinder proto, like that. So define vrep cylinder. It's going to take a radius and a height for sure, and it's going to return a function in u and v, just like that. So we're going to let let me also go back to old drawing area, parametric. Let's get the circle function here. Have a look at this. So the circle let's have a look there. We could use this as a basis for, so this is also parametric, but it's going to be parametric in only one. It's going to be parametric only in one dimension here. So the only difference actually is, let's see if this makes any sense. We're gonna have, right, let's make U be the mapping over math pi. So U, if you imagine a cylinder cut vertically and then unwrapped like a piece of paper, U is going to be kind of along the circle part at the bottom. So it's going to be, the bottom corner is 0, and if you go to 2 pi, that'll be the other corner. And then V is just going to be the vertical position on that same thing. So if we assume the cylinder is extruded along Z, then we actually have a pretty simple approach here. X can be math cos u. Y can be the same, math sine u, times the radius. Neither of those things need height, and then z is just going to be, so that's u, and then v is just, it has to be times h. Does that make sense? I think that makes sense. And then, so actually this is redundant, but for consistency, right? U and V are those things. And then Z is V, X, Y are functions of U. So Z is V because let's imagine we give, so the height of the cylinder, let's say is 10, and we give V 0. So 0 times 10 is 0, which puts it at the bottom. Let's imagine V is 1 and the height of the cylinder is 10, right? That means 10 times 1 is 10, which is exactly what we expect. If V is half, you go to half. Okay, so one thing I haven't built into these is clamping, right? They don't stay within their max. They technically expand infinitely and stuff like that. So that's something to fix, obviously. But if I do this, I should be able to return x, y, z, no problem. Let's see if that makes any sense. Let's define, well actually, so given that, we should actually be able to just go ahead and create a new function here. Let's make the same random grid, but let's actually go here and do def cylinder a d slash brep cylinder, taking a radius, let's do a radius of 100. No, let's do a radius 80, and then a height of 200. Let's try that. Right, so given just this, first of all, let's refresh this. Did this save, by the way? Save this. Refresh this just to be safe. This here, XF triangles, if I just change this sphere to cylinder, it should work. It does work. Okay, so that's really cool, with the obvious problem that at the extents here, right, we run into, like, it's not, that's going to be one problem with my triangulation assumption here. They're not triangulating, like there's no way that they're stitched nicely into each other. I would have to fix that somehow. And I don't know how to do that yet, actually. That's going to be a tough one. But it looks pretty cool, if I do say so myself. Let's zip that down to 100 only. How about that? Let's also change the diameter of this to be 120 and this height only 150. Let's try that. See what it looks like. It kind of looks like nothing. Let's try realistic units here and then just scale things up. I think that's going to break it. I don't remember. Yeah. That is breaking because of the fact that I'm scaling from every individual triangle's center point. So in order for this to work, I have to do this, svg/g, group them, and then that should work. Yeah, sweet. Okay, so let's imagine, so I want to use this to make like cool looking desk legs or something. So let's come up with heights that make sense. Let's say it's gonna only be 5 inches in diameter. No, let's do 2.5 inches in diameter. No, this is the radius, so 5 inches diameter, like I said originally. And the height, let's assume, is going to be 40 inches. See, that could look really cool as like some kind of desk leg thing, in my opinion. But the obvious issues come up when I actually if I were to build this, right, that bottom is no good to me that way. It's hard to read the shape of this, eh? I also do want to, so I scale it 10, but I also want to oh no, that shoot. You know what? I'm good with it for now. I don't want to invent translations for 3D shapes yet. Let me scale it 2 times, 4 times. Okay, that's really cool. What can I do with this? That blue hurts my eyes. Oh, I have another little thing I could do here. If I make the height of this 800, then I can see more of it, like that. Because I'm being a little bit lazy. Okay, let me now change this to be something that doesn't kill my eyes. Slate gray. I wonder, let's try something here. Open SCAD. Polygon, no, polyhedra. I want to see something here. So this is a different program, and I've used it before. I'm just wondering if I can use this function to double check the rendering of this shape to see if it actually makes sense as a proper shape. The most general 3D primitive solid. It can be used to create any irregular shape, including those with yes. Okay. Okay, so vector of 3D points. Do I even have OpenSCAD? I do. Let's see. Let's see if I can use this to my advantage somehow. Let me do, let's have a look here. I don't need a function. I need basics maybe. Well, I don't know. These old examples will be helpful. Let's just open one at random. How about that? Okay, we've got, what do we have here? Let's close the customizer. It's been a long time since I've used this, so I might be a little out of practice here. If I do, let's just start here, cylinder 2020. And how do we rebuild that? Oh, okay. Let's try to change the view of this for a minute. Let's see what kind of color scheme looks good here. Tomorrow night color scheme looks good there. Let's go to the editor. That's fine as an editor. Monakai, that's nice. Tomorrow night. Let's do that. That looks cool. I like that. You know, I'm comfortable with it. Oh boy, let's go over here. Right, polyhedron. Can you call it with just points? Oh no, you do need to use faces. Vector of faces that collectively enclose the solid. Each face is a vector containing the indices of 3 or more points from the points vector. Okay. Faces may be defined in any order. Define enough faces to fully enclose the solid with no overlap. Right, so this won't work for what I'm trying to achieve at the moment. It would work with a sphere, I think. Maybe I should make a little function that, oh boy, this should be all like this. Scad if I give this function a triangulated surface, so a list of triangles, then I can return, I can make points, let points be apply concat to the triangles. That's all of the points. And then the faces would just be, what's the shape of faces here? Faces is gonna be point. Okay, so yeah, so indices, right? So faces will just be partition 3 of range count points. So that's the faces. Right, so then in order to produce a valid call to polyhedron, what you do is make the right syntax, which is going to be string polyhedron points equals right, and then here what you do is actually you have to do apply string, no, here I can do apply string to scad point string point. Given that point, you do string, no, you apply string to this list of things, which has an open bracket here, right? Then it has let's do it this way. String open bracket. Then apply string to interpose comma and a space. Interpose that with point. And then you close that off with a closed square bracket like that. That should scad point string, if I give it a 0.000, that's correct. Okay. That'll actually work, yeah. So if I do apply string to interpose that with map scad point string over scad point string over the points. Okay, that's that one, and then you end that part with close that like that, and then you do new line here, and then you do faces equals open bracket. And then here you just do apply string to interpose that with map scad point string to faces. Then you end that with faces is going to end with convexity equals n equals 10 is just a good default, I guess. for convexity. That should be fine. So I just end that list of points with closing that and that. Then convexity equals n. Okay. I think that should work fine. Wrangle. Wrangle, range. There we go. Okay, so SCAD polyhedron should be usable now to make a string that... Ooh, by the way, can I do open? I should be able to do... let's well, let's not let me do this for a second. Okay, we have big old thing here. Right. What we're gonna do is run this new function, SCAD polyhedron, over if I generate sphere A, let's see what happens if I do. Let's try this. Render triangulation, triangulate surface, random grid. Cylinder A doesn't exist. Let's go like this. Random grid is that thing. Don't need this or that. Okay. Okay. Now, first of XF triangles is just, okay, good. If I now do SCAD polyhedron of XF triangles, it kinda looks like it worked. Spit into test.scad. SCAD polyhedron of XF triangles. Let's see. Okay. Is that going to be a valid SCAD file? I'm going to open it up, but I don't want to open up bad stuff or stuff I don't want people to see in my file structure. So, let me just open it up for a second. Hopefully it works. We'll find out soon enough. Oh, convexity equals n. That's wrong. Okay. Oh, of course, the obvious problem is, okay, so what I have is Okay, we're at a spot here where, okay, so what I've done here, save that. If I spit that out there, right, it reloads and displays here. Now, the issue is, can I make a wireframe view? What? Convexity should not be N. Cool, okay. So, the problem here is I have 2D, I put the wrong triangles through it. I need to put if I def triangles, I need to not render it like that. I just need to triangulate the surface. And now if I spit that, it should be 3D. Hey. Okay, that's pretty cool. So this is kind of working. It looks like it's making a valid shape here. Where it's wrong, obviously, is things like this at the top here. It's, oh, and in fact, it's split. It does not close, so it is just an open cylinder, right? So this is, let me see, I'm gonna try and make a pretty massive, okay, take 500, it's gonna be big. Okay, right, so this is a cylinder with a random Delaunay triangulation on it, but here, you see this? That split there is because of how I'm triangulating only up to, but not including 0 and 1, and I'm not triangulating it in the 3D space, I'm triangulating a 2D unwrapping of the shape. So there's going to be, it's a full, like it's discontinuous along this joint, basically, there. It's also not capped, because this bottom thing and the top thing would be separate surfaces entirely. You're getting triangles covering it because I suppose one of the points happened just by more luck than anything. There's a triangle covering it perfectly, but if you increase the number of points in the triangulation as well, it'll more and more just look like a cylinder of a piece of paper with no top and bottom, and not ever meeting along this crevasse here. So I don't have a solution for that yet. What I am happy with is this thing kind of working. It's pretty cool. If I do this with sphere A though, I wonder what happens. So this now should look like a weird old ball, and that's pretty cool. Okay, I'm happy. This is fun. This is really neat. So that, I don't know if that is just like a really, I don't know if that's an error in there. I can't tell. It looks like it's actually a valid shape there. Let me go wireframe and see what this thing looks like. Oh, it didn't. View, surfaces, view, Show edges is what I meant. It's not doing any of that. Pourquoi? Perspective, ISO. It's not working with the show edges for some reason, but that looks pretty neat though, I think. See that, how at the ends it, oh, there's almost surely some errors with yeah, there's some triangle overlap errors and stuff there. So this stuff here is, I have a naive implementation of things that don't really correct for errors and things like that. So you're gonna get like floating point errors, kind of end up causing these weird sort of things at the extremes. But this looks like some kind of low poly video game thing. It's pretty neat. If I then go back to the definition of the random grid here, if I only take 100, that'll change it again. Oh, okay, so now it's showing all the edges. Oh, so here we do get, see this here, this is indicative of invalid triangulation. So I wonder, I don't know, some of my assumptions are just wrong, I guess. Let's go back, let's go crazy with it, see if this breaks things. It shouldn't. Did it actually work? It looks like it did. This is a lot of data all of a sudden. Oh, no, that won't change it because, right. I have not redefined this. That will take a while now. Spit. There we go. Okay, so that's even tighter. Render that. So here, what I don't know actually is, like, if this were, if I were to send this to a 3D printer, is this correctly watertight, or is it, does it have invalid faces in here? I think it probably has invalid faces, but I don't know. It's hard to tell. I could run it through like, I'm sure there are mesh checker programs. Pardon me. Sorry about that. But I'll get to those another time. I just, out of curiosity, I would like to see one final time what it looks like if I do cylinder A with a bigger grid, and then spit that out. Okay, see, that's cool. I can't see anything though. Okay. Right, so, oh boy, gets a little hard to I want to just spin it. Oh, right. So there's still, you can kind of see this split along here. No matter what I do, no matter how fine I turn up the triangulation grid, no matter how many points I get there, it will never actually triangulate as if those were connected. And that actually, like if I were using this triangulation method for doing like materials analysis on a mesh like this, that is unacceptable. All of these triangles are going to be way too thin, so they're going to have a really high aspect ratio, and that's not going to be good for, if you run an analysis, it's not good for doing interpolation across of any value across something that's really long and slender like that, because it can lead to drastically incorrect. Why is this not? Anyway, it can just be a big, huge problem. Let me now, actually, one final thing, and then I'm going to get going, I think. If I make this random grid only 50, please. What does this look like? And the reason I want to do it is want to try something like this. Let's, there we go, kinda. Okay. This is closer to the total number of triangles that I could actually make by hand for the idea I have. If you go really fine with your mesh, it'll look more like a cylinder, but it'll be pretty much impossible to make the triangles by hand. If that makes any sense. In general, the other thing I realize is the reason that this grid or these triangles have a long, they feel sort of stretched vertically, is partly because both parameters u and v go from 0 to 1, and I'm randomly selecting equally from each of those in equal ratios, you could say. But if you unwrap the parameter space that they're on, it's a really long cylinder, right? So the u parameter, evenly spaced, has a shorter distance than the v parameter, evenly spaced. So technically, I need to increase the samples in the v parameter space direction by v times, I need to sample it more times in relation to the ratio of u to v, because it's not a square. So I have to smush it in the v direction to make it as if it were a square. That's another reason why all of them are so slender in this direction. Can I make that obvious? Right, so what I need to do, how would I do that? It would have to be, well, I didn't set it up this way, but basically you would have to use random numbers with different ranges, and then you remap those ranges into 0 and 1, basically. I think that would make sense. Anyway, this is pretty cool. What I like is actually I've got this sort of additional way that I can view the data I'm creating. So this I can also see it here in this document here, which is, I think, really cool. One obvious problem, if I save it, it changes, so it's never going to be the same. But this is pretty cool. It's a pretty neat start. All right, that is going to be enough for me right now. I have to probably get going. Hey, wow, why is that? Oh, because I scaled it 10 times. That looks funny. I mean, some of these things look pretty cool as like abstract sort of pieces in general. String rand. Huh. Well, now I'm not doing anything anymore. It's just cool. I like it. I'm not doing anything important. This just looks cool. Okay, that's gonna be enough for me for the day. I have other things I need to do. Yeah, I gotta get going to the gym soon. But I'll be back tomorrow. I wanna flesh out the idea of this sort of random triangulated grid thing again. Maybe work on even more complicated surface shapes that I could use to make a sort of cool looking desk leg sweep, and then triangulate over that, and then take the triangulation of that and turn it into a document where I can bend those triangles myself and assemble them into some cool shape. I think that's going to be really hard, but I think it'll be a lot of fun. So I'm going to try it out, and I'm going to get going now though. So if there's anyone watching this after the fact on, say, YouTube or on the Twitch channel or anything like that, first of all, thank you for doing that. Any little view is helpful for me. That engagement is positive reinforcement for me to keep doing this. But please, if you can and you want to, give a follow, give a like, a comment, a subscribe, all of that normal stuff. I know you hear it everywhere, but the reason you hear it is because it is helpful. And if you enjoy the content that I'm making and think what I'm doing is interesting, share it around. That is totally helpful for me. With that though, thanks for tuning in, thanks for watching. I'm gonna get going. Have a good one.